if we look today at is the clicker work? Yeah. So we know that daylight is very important for human beings. It's really vital to have daylight in the working environment. When modern architecture has a lot of daylight, a lot of light coming in with large facades. So that's great. But with that also comes a disadvantage. Sometimes sun and glare can lead to overheating and lead to stress for people in a building. That's why there's a lot of solutions, and some of the solutions people come up with are shading solutions, blinds that are used to reduce that. With that also comes, a trade-off that you lose that connection to daylight, you lose that connection to the outside world. And if you look at some of the studies, you see that's really something that we will deprive on and actually has an influence on absenteeism. So we as Eyrise, we came up with a solution. But first this one. So if you look at, you get dynamic mechanical systems that can go up and down, that can bring a solution. But of course, when there's too much wind, this is problematic. It can't be used. And also, you know that these blinds are staying down often much longer than actually needed. So half of the time you'd put them down in a building anyway. Static solutions could also be nice. I mean, I know very beautiful solutions architects created with static solutions. You see them around here, actually, a lot of those in this country. Very nice, but if you have a dark day, you also lose all that potential, sunlight, and even in winter, that solar heat gain that you could have. You also lose that momentum, that possibility. So what we came up with and is actually a solution that is derived from a technology in liquid crystals. So Merck is the parent company of Eyrise and is a producer of liquid crystals for displays. And we noticed, hey, what if we put those crystals in windows for architecture, and we can create a switchable, a dynamic product based on those liquid crystals. And that's what we actually did. So using that long time experience, almost 100 years, the liquid crystals are around, we used that experience and put that into the glass industry, where we had to learn a lot, to be honest. It's true. And with that, actually, we are able to create a dynamic solution where, you get the protection when you need it, and you get it in 1 second. You get it extremely fast. Why is that speed necessary? Not because you want to make a disco out of your building, but because it's important to have a fast reaction to changing weather. Depending on the country you're in some countries, when the sun is up, it's up for the whole day. But I'm from Belgium, not the case there. It can rain and sun and clouds again, and can change all the time. And I think, there are many countries like that in the world. So I think there you might need to adapt to those kind of solutions in the market. So how does that work? Liquid crystals are embedded in glass panes as a liquid. And we mix that together with dyes, with a black dye that has almost the same shape as that crystal. When changing voltage on that mixture, you basically change the orientation. The liquid crystals push those dyes also in the other direction. When they're in a horizontal way, you can see through, you have a bright state of the glass, and when they tilt to a vertical position, they block more light. That's basically the principle how this works. You can also, it's not only on and off, you can do any stage in between to get any kind of shading you want at a certain moment. So really, if you see, this is a picture from an installation we did at the German pavilion at the World Expo, where you see different stages of the glass, where you can really play with that per panel by panel. So only that isn't enough. So that is a cell in which that switching goes on. But we need those cells to be built in a build-up, which makes sense for the industry, for architecture. So as a IGU, can be a DGU, can be double glazed, can also be a triple glass unit. The cells, and we use 2 of those because they're super tiny, so the space in between is a fourth of the thickness of a human hair, so it's really, really very tiny. We want that uniform color all over, that's why it's so thin, and we need 2 of those, but it's really thin glass. They're laminated to an outer pane, so we're really at the outside of the building, and then on the inside we make the build-up for an insulated glass unit. Obviously, we're talking about a dynamic product based on current, or on voltage, So we need a cable. We have a cable connection. At the installation, there's basically a pigtail that is easily just to connect with a cable that goes to a driver, and that driver can be connected to different options. Could be via KNX, could be something else, could be digitally, can also be like an analog connection to basically switch any panel you want. You can create groups out of that. You can create a completely automatic system or a completely manual or anything in between. That's a setup you can always make, that actually the client is deciding how they want to switch that. So dynamic glass is not new to the market. So why do you need a different solution here? Well, you know that there are solutions already around electrochromic glass, and I'd like to show the difference between the two. So electrochromic glass is actually an electrochemical reaction. So because of that, it takes a bit of time to respond. It's a bit like a lithium-ion battery that doesn't load in a split second. It needs a bit of time, and that chemical process has an intrinsic bluish color to it. I know there is improvement in that market as well, so I don't want to make it completely, but I want to show you the difference of technology more than ever. And in liquid crystals, it's driven by voltage. The liquids are liquid between the glass panes, create a uniform and an instant switch because they're free to move around easily. So they instantly move. This technology comes through your TV, which switches how many? 100 hertz, 50 hertz, it's super fast. So that's basically where we're coming from. It becomes color neutral, and it's also switch fast, as I mentioned already. So it's basically different principles, different systems of these technologies, right? And with that, we don't want to be in a place where we look all like corpses, or we want to eat a blue banana. So basically we say, well, color neutrality is an important aspect in a building, in a workplace, certainly when this is a place where food is served, for example, and also in a museum, this is an important factor. We did one project also where this was the most important factor. They have like the exact color rendering, not to change the artwork, to respect the artists that are presenting there. So architecture has been always about a balance. For ease, I forgot about the budget, because it's always within a given budget, of course, aesthetics and functionality are your 2 main elements you play with. Bauhaus with form follows function and everything, we know all that. And I think, and it's not new, but in the last years, we see more and more a third factor that is a challenge, that is, in that balance, that is sustainability. It's not enough to make just a nice building, to make a functional building, but it needs to be also sustainable as we go. And more, this will be an important factor in the industry, because today, probably telling nothing new, but 40% of all global carbon emissions come from the building industry, from the built environments. All buildings together, not only houses, not only offices, everything. About 27% of that is embedded carbon, is operational. So all the emissions you get from building operations, and 13% in the embedded carbon in the building. So this is a study we found that you can look it up. So we really see this is important, and we see that the industry is really looking at that actively and looking for solutions. Even if you dig deeper, you see that about 5% of the building stock are large buildings in the world, and they account for 50% of those emissions, so 20% of the global, if you would calculate that together. So that's why also for us, we focus on a solution for commercial buildings. We see that we can make the biggest difference there. And also we see that we try to support together with our customers. We realized, hey, we can do something here. We can contribute. And I'll try to explain you a little bit how. Green building certifications, GDB scores, are an important factor to get these goals. So ESG standing for societal, economic, and environmental factors. So these green building certifications, most of them are all based on the UN, the United Nations environmental goals. And they have these three pillars. It's society, it's the economical part, and it's the environment. So it's not enough to only contribute on, I reduce a little bit of energy, I save a little bit of CO2 emission. Yes, very good. But this is actually much larger. I'm not going to all the details, but for example, the societal part, it's the human part, is also very important. Sustainability is not just only about emissions, it's also about how we as human beings thrive in our environment and in our buildings. And that is a factor that is also very big into those. So it always has these three factors, and we learned that we can contribute on those factors. So I give you an example from the Swiss, without going too much into detail, but on the Swiss standard SNBS. So big chart. What basically how it's built up is, again, you see those three, society, economy, environment, those three factors, and then they are divided into different topics with subtopics underneath those. And you know, when the highest certification, of course, you can tick as much boxes as possible, right? So again, if you would only talk about energy saving, any energy demand, it's one of those factors. That one box you can tick, that won't help you to get that certification. So you need to be really looking beyond that and look a bit broader than that. And that's where we see that there are much more factors where we can support you. We can't give you that black and white because all these things are very much building specific, obviously. So we really look together with you to the project. What can we contribute? How can we do that? What can we do together? How can we support you to get there? Which kind of data we can deliver to get you there? The Swiss certification is not the only one. There are many more in the market. DNGB is a German one, is well known as well, and the LEED standard also. So all of them, we see there are small variations. The WELL standard, for example, is very much about that human element, about wellness. And the LEED is a little bit more about the building itself. So there are small differences, and it will be probably the building owner who decides which one they like to go for, or in which case it makes sense for them to go for such certification. It's not cheap, but certainly if it's an investor who wants to have a tenant, win a good tenant for the building, they probably will do that because a high-end tenant will have a checklist on their own for sustainability. And they will say, well, if we can tick those boxes, that's a building we want to rent, and we're even wanting to spend premium price for it if it ticks those boxes. So that's the whole driver of these solutions. So you see, this visual acoustic comfort is an aspect in that, where, as I said, the dynamic system brings that visual comfort because whenever you also, in every stage you always have that view outside. Even if in the darkest stage you have only a G value of 4% or 3%, you have still that outside view at any time, at any given time. Some examples of projects we're currently working on. So it's not only theory I tried to bring you today, but really show that we are really working hard to bring buildings to realization. Some have been realized already, some are in the process. In different places, mainly in Europe. We focus very much on Europe because we produce in the Netherlands and in Germany. So we also produce locally in that sense in Europe with short distances. But that's also why we focus also on European market for now. And what we see is, most of those buildings go for green certifications, and a lot of them are also owned by real estate companies or corporations. So just to see, this is an example where you see from the outside, you get not only, I talk about, the functionality of it, but I could also say, like, you have that uniform look. The switching variation between bright and dark from the outside is visible, but not extremely visible. It's not like blinds having all over the place. So in that sense, this is, you're jealous not to work in that kind of place, right? With that kind of view. But even there, you want to lose that view, but you have to protect yourself from low sun. We see a lot of projects in Switzerland, in Germany, where you think, well, why not in the Middle East, where you need that sun protection? Well, actually, what we see is that buildings in Europe are highly insulated, so the chance for overheating is actually quite big. So you need to get solutions there that also are dynamic and adapt to the environment. Another example I mentioned before that potential tenants are having a checklist. We had that case with a building from the company Swiss Prime, which is the largest investor in Switzerland. They could win Google as a tenant, and you can imagine, they don't go for the cheapest and the first building they find. We were able to win because of those green building certifications. It's not only for the gimmick, oh yeah, that's cool, it's a new technology, let's do that. Yes, that helps, but there's also the factor of sustainability, of greening, building certifications that help them to convince to go for this project. And actually, financially, they gain the investment back in no time. Can't give you the exact figures, but if you go to their website, you see a little bit of what I mean. M-Yard is another project that we realized, or we're busy actually, it's in the process of realization. There's a large roof on top with a view to the Alps. You don't want blinds there. It will actually be almost impossible to have blinds there. So it's a great solution on that building to have a dynamic glass solution installed here. Another example, this is in Brussels on Avenue Louise, a project by Hugening Architects, and this is a CLT, so cross laminate timber structure. And the great thing is, in their project also, it was about Eyrise, it was about dynamic glazing as one of the solutions. They were the only architectural firm that suggested keeping the existing structure. All the others says, let's demolish the place, let's build something bright and new. Well, they said, no, let's keep that concrete structure. All that embedded carbon is there, let's keep it. They had challenges with that. The lower ceilings were a problem, but they were able to put all the HVAC, all the cabling and everything actually outside of that. So they were able from the city to extend the building in 90 centimeters outside of the space from the first floor onwards. And in that way, they could bring all the technology there, all the technique there, and have the ceiling maximum height, and work with an existing structure, adding new technology, including Eyrise, and with that also come to a sustainable and nice work environment. That building will be, they're actually now installing the glass as we speak, so I hope that we can show you more on that in the near future. A last project I'd like to highlight is BAFTA. BAFTA is the British Academy for Film and Television. And when they did a renovation of their building, it went really thorough. So this was done by Benedetti Architects from London. What they did, they discovered historic skylights, Victorian skylights under the roof, under the ceiling. They decided to lift the whole floor upwards with one level and create a new space as a membership area. They increased the amount of glass in the building. I don't know the much percent, but they increased it a lot. and at the same time, they were able to reduce their energy balance. So they were able to reduce the spending on energy for this building because they were able to install and make like a marriage between historical construction here and Eyrise glass on top. It's up to you to see if you like that, if you don't like it, if it's your taste or not. But for that building, it's a great solution because in that space, it can get quite warm. Even in English sun can get quite warm there. So then the dimming of the glass going to a darker stage, reducing the heat, reducing the direct sunlight there, creates a space which is much more nice to be in. So this is the feedback we got from the head of property, for example. So their EPC is lowered. So this, it's from, it used to be like a G, and now it's down to a B. Depending on the country where you're from, I know you have to read these things slightly different. So, but in the UK comparison, the B stance is almost similar like a new build. So in a historical building, there are even there possibilities to integrate new technologies and create great spaces. So with that, I like to come to a summary and probably also maybe open for floor for some questions. But what is important also is that we try to bring you a solution for solar protection. So if you compare Eyrise glass with normal glass, you will see differences, big differences. But we suggest you to compare a solar shading solution, standard solar shading solution, with a dynamic glass solution and compare those two on both carbon footprint or on costs. So I think it's what we like to say. We contribute to building certifications on various levels. As you see, to get that higher certification, you need to tick multiple boxes, not just one box. And also we can say that we bring a smaller carbon footprint when you compare different shading solutions with Eyrise. Shapes, we can make different shapes and also adopt. And at this moment, the maximum size that we can make is 3.5 meters high by 1.6 meters wide. That's just limitations we have on our new technology, on the machines that we have at this moment. But you know, there's still growth for the future for us, we believe. It's a new technology, but we're proven in the market. I show different examples. We're there. We're installing things. Larger investors believe in this. So we're very happy to see this happening. And as I said before, also, you know, each panel has a connection, has its individual connections. So you can always rewire or basically reprogram. You don't have to rewire, reprogram the glass switching any way or anytime you like that. So with that, I conclude and I thank you for your attention.